Hello and welcome to Straight Talk, Supply Chain Insights, the podcast for your supply chain leader who is on the go and wants to be in the know. And now, your host, Lora Cecere.
My name is Lora Cecere, and I want to welcome you to the second session for the technologists and consultants on how do we rethink processes outside in. And our goal is not just to define supply chain management and supply chain planning, but to redefine work. So if I'm successful, I'm going to have technologists and business leaders use new forms of technology to redefine work, to eliminate waste and improve insights. And as you can see from some of the work that I'm going to share, that's a great opportunity. And I think it's an amazing time for us to do this together. So let's get started. So last session, we talked about what is an outside-in process. We defined it and we contrasted an inside-out with an outside-in process. And I gave everyone homework to do around forecastability, where I gave you the coefficient of variation exercise, simple exercise, but it's very revealing. And it starts the discussion around demand flows and the fact that we don't just have one supply chain, we have multiple that have different flows and different capabilities and characteristics that we can mine to drive insights. And today, since most companies treat supply chain as one flow, they miss the insights from regional flows or new product launch or demand shaping. And there's tremendous insights that we can gather to improve the opportunity and reliability of the value chain if we can capture the channel insights and be able to mine the patterns to be able to deliver a better and more consistent response. So today we're going to talk about demand. We're going to talk about how do we define the flows, mine the flows, use the flows, and how do we navigate the river of demand upstream and downstream. Next week, we will move to supply, where we'll talk about bidirectional orchestration and the redefinition of taxonomies. And then we will have some sharing by the people that have actually done testing to talk about what did they learn and the change management issues and the unlearning process that needs to go on. I don't think it's just change management. I think that we have to learn from the past to unlearn, to rethink what's possible. And then we'll talk about how we use the insights that you have learned in the fifth class to be a change agent, to test and learn, and to work with others in the class to be able to pilot and to share some of the insights of your work. So again, no such thing as a dumb question. You know, you're not be able to answer me the question live, but you can ask it in text. I answer every email and every text in LinkedIn. You have your study groups. Hopefully this is a good opportunity for you to do some work with your study groups. And my goal is dialogue, because nobody knows the answer, and we're on the tip of being able to redefine something that I think is important. I'm going to start and stop on time, and I'm asking you to please do the homework, because that will help you to better understand the insights. So we're going to rethink demand, think about it as a demand flow, and then we'll wrap up. So in the homework exercise that I asked you to do, I asked people to measure how much of inventory is safety stock. And the goal of this homework exercise was to have people think about the fact that 15 to 20% of inventory is safety stock, but actually that's all we really manage in conventional advanced planning systems. Now you might say, well, don't we manage cycle stock? Well, perhaps if people are measuring schedule reliability and they're actually following the output of factory scheduling. However, I find that the deployments of factory scheduling and cycle stock have actually degraded over the years, and 28% of our manufacturing is contract manufacturing. So I think there's a great opportunity for us to move from just focusing on safety stock to looking at form and function of inventory holistically, and the design of inventory as a buffer. The other thing I think we learned from the homework is that we do not have one definition of safety stock, and people don't think about safety stock as, what is really working and the design of a buffer versus waste. So a discussion that we had with a line of business users. The other thing is the analysis of coefficient of variation, which is looking at variability of the demand flow. And we find here that people have more than one flow. So I asked people to look at turn volume, and these are items in a make-to-stock supply chain that are made regularly. We threw away seasonal, and we threw away new product launch, and we threw away things that were heavily shaped just to make it simpler. And we find that there's more than one flow. And we also find that unforecastability is real. And 80% of the homework that was returned, we had coefficient of variation up in the 0.7 range for medium to low volume. And in one case, I actually had 0.7 in high turn volume. So there are issues in deployment. Maybe we have dirty data. There are issues in the fact that history is not a good use or proxy for demand. And we also have issues in that many people don't know how to test if they're getting a good output of demand planning. The focus is on quick deployment, not necessarily am I getting a good answer. So unforecastability is real, and we don't really have a lot of discipline for forecast value add. And again, you know, the way that I see it is coefficient of variation when it's under 0.30, it's very forecastable. Conventional models work really well if they're deployed correctly, and that's a big if at times. And the coefficient of variation of 0.30 to 0.7 is, you know, maybe forecastable, depends upon the models, and we have to use some different models, either attach rate forecasting or attribute-based forecasting or product profile planning. Many people don't know about the differences in the models, and that's an opportunity for the technology vendors. But when we get into the coefficient of variation greater than 0.7, it's probably not forecastable using conventional methods. And so the question is, what do I do? And so 90% of the homework had coefficient of variation in medium and low turn volume products. So we've got unforecastability as a theme that's running through some of this work. Now, one of the opportunities in conventional models is to backcast, to take 2 to 3 years of history. And that's problematic right now because we have pandemic history, but the opportunity is to set up an instance, test the optimizers, and basically find out if we have improved forecast value add. Now, often I find technologists will go in and they'll do an assessment, and their focus is on kind of upgrading and getting to the next technology versus looking at how clean is the data and how do I get the right optimizer for the right stream and get a better forecast value add. So actually fine-tuning the optimizers, I think, is an opportunity for all. And in the class, I only had one student in the North America cohort that says that they knew what backcasting was and that they had backcasted. So we had a discussion about, you know, how would we go about this? And the analogy I use is, you know, if you own a car, you will never drive a car multiple years without going and getting the oil changed and getting the tune-up, or you'll run into problems. But I find that many times people will install advanced planning systems and they'll leave it and forget it and never do the tune-up of the optimizer, and they don't really understand how to do that. So when I talked about setting up the instance, getting the data, and basically hiring the current technology company to come in and do the optimizer tune-up, that was all new to people. They just don't understand how to do this. And so I think that's an opportunity for people. You know, it isn't about installing the technology, it's about, am I getting a good answer? And I find that 70% of the class doesn't know the concept of forecast value added, you know, and it's saying, you know, am I getting a better forecast than the naive forecast based upon what's happening? So hopefully you've read that work. And, you know, the old model that I used to use back before I was, you know, really delving into the outside-in processes was we have some opportunities, you know, in the conventional world of the current taxonomy to improve sensing. I can put in demand sensing technology in the operational horizon to improve consumption logic between the tactical and the operational horizon. and basically drive a better answer in that fulfillment horizon. Now, there's probably about 25 deployments of demand sensing that happened in the last 2 years, but most of them went afoul because it was primarily focused on distribution logic and didn't actually carry over to manufacturing logic. So, there's a need for the redefinition of the taxonomies. And a lot of times people will use the term demand sensing, but not really define it. And I use demand sensing as a demand optimizer that is in the operational horizon, which is usually 12 to 14 weeks from the order cycle, and replaces order consumption logic, which is what's in conventional advanced planning tools. Now, there's also an opportunity to do unstructured text mining and to bring in causal factors or indicators based upon what we're hearing on social listening. Again, most people don't do this, they don't understand it, and also the use of point of sale data. Now, one of the big barriers of the use of point of sale data is that people think it has to be perfect. They don't understand that with pattern recognition and with some advanced analytics, I can have partial data and it doesn't have to be perfect. But one of the issues is that most people have deployed a demand model that's based upon a ship from location, not a ship to location. And because of the differences in the definition of location and because of demand latency, they have a hard time synchronizing the demand data from point of sale. So often the point of sale data, because of demand latency, will be 4 weeks to 2 months out of sync with an order data. And the demand location has to be harmonized. So, what I find is the best use of point of sale data is to define an outside-in model and basically synchronize with the channel and use the point of sale data and that latency and use the order as an indicator. So most of our conventional models do not allow us to use point of sale readily, even though in consumer products and food and beverage, the point of sale data is used by sales account teams. And they are getting the insights, but that data, because of the lack of issue or the issues with synchronization, is not used in supply chain. And likewise, the VMI programs, which I find many companies have 30 to 35 VMI programs, only comes into order management and is not used by the larger organizations. So we're drowning in data and we're not using it. And our conventional models are really very much a ship from model using order data. And if you know anything about demand planning, you basically, design for the outcome. And so the outcome that we're designing for does not allow us to use channel data very readily. So when we have data that tells us that our forecast is not forecastable, we have the option to postpone, and most people struggle with the design of postponement, but late stage postponement gives us a lot of flexibility. We also have the ability to change the models, to be able to look at, personalization or platform rationalization or attribute-based planning or new profile planning or attach rate forecasting. And so there are different models that we can use depending upon the industry. I love attribute-based models for new product launch and apparel. I also love new product profile planning for new product launch. And I love the platform rationalization attach rate planning for things that are configured to order. So we'll talk about that more in the supply section. But this balance between sensing and responding has some opportunity, but not nearly as much opportunity as if we redefine the platform to be outside in. And to do that, we've got to throw away some of our current conventions, right? So there's a belief that, customer service on time and in full can be balanced with safety stock inventory and cost. This is an oversimplification of the supply chain because it isn't just about safety stock inventory. It's about form and function and the design of the inventory strategy. And it isn't just about cost. It's about margin and it's about total scorecard balancing to be able to work this. And so I find this is a very limited view, often used by supply chain leaders, and we've got to change it. So let's rethink demand, right? So the first thing is, let's get clear on definitions. I'm kind of definition Lora, right? And, we've got to say, what is the role of the forecast? And you might say, wasn't that a stupid question, Lora? Isn't the role of the forecast to drive replenishment? And I'm like, no, we've got to unlearn that. The role of the forecast should be to align the entire organization to drive better outcomes. And those better outcomes really should be tied to the operating strategy. So why should we drive a replenishment signal and leave procurement in the dark, right? Why are we not aligning demand through the supply chain for procurement and transportation to be able to drive opportunity for bidirectional orchestration? Let's start that journey. So the first thing is, let's get clear on definitions. A sales-driven forecast is really alignment to sales collaboration. This started about 2003 after we did some work with collaborative planning and forecasting in retail. And I have never found an organization that I've worked with, and I've worked with about 600 organizations, where a sales-driven forecasting approach improves forecast value add. Now, it's important we get clear on forecast value add. So forecast value add says, is my forecast better than the naive forecast? And the naive forecast in turn volume is often the average of the last 3 months of sales, right? And we'll find that salespeople are very coin operated, right? I love salespeople, but they're very coin operated based upon their bonuses. So they'll either drive a high bias or low bias, or they'll try to sandbag, a particular product that they want to basically make sure they have in the market. But a sales-driven forecast for most organizations is a big mistake. A marketing-driven forecast, where we're looking at, what does marketing think we're going to sell, is also a big mistake. Marketing is not incented to have accuracy in their forecast. And, a new product launch will often have 70% error and 150 to 200% bias. And there's nothing that really aligns the marketing forecast with what's happening in the market, right? There's a big difference between marketing driven and market driven. And so market driven is really aligning to the channel. And most marketing plans are not aligned to channel potential. And, if you're an old gal or, student of supply chain, that you've got a lot of scars from a marketing forecast having an overbias and, making more product than we should, or a lack of alignment with the market. A budget-driven forecast really constrains the forecast based upon the budget. And this is also a big mistake, because the budget is a slow process, and the budget is out of step with the market the minute that it's actually published. And most budgets carry with it a alignment issue, in that people will sandbag the budget to make bonus incentives, and so that will also drag the organization. So I'm a big proponent of a market-driven forecast, one that's based upon market signals, point of sale, weather, events, drivers, and one that is actually moving through the organization based upon flow. And this is the challenge in the change management, because an inside-out process is not market-driven. It is order-driven, and it's based upon history. And there's an assumption that history is a good proxy for demand. And hopefully, if you've learned anything from the Lora Cecere blogs and your work, you know that history is a bad signal for demand. The other thing is, this is our current taxonomy. Our current taxonomy basically does functional optimization, deploying optimizers within boxes. And each of these boxes will improve the functional outcome of a particular process, but doesn't really drive improvement for the total supply chain. So let's look at something like production planning, right? Production planning will optimize a production cycle for a factory. And often it's tied to improvement of operational efficiency, OEE, or total manufacturing cost. But OEE and total manufacturing cost will drive the supply chain out of balance because it will actually give you higher inventory and potentially higher costs. The lowest manufacturing cost will not necessarily give us the best total cost because, you know, as we have these optimizers lined up, we're trying to drive the best transportation costs, the lowest procurement costs, the lowest deployment costs, and those are not aligned at a network design level, which throw the supply chain out of balance because those functions are competing with optimizers, right? And the workflow is cumbersome and most people don't use their tools. There's a reason why 90% of planning is done on Excel spreadsheet. We haven't made it very easy to use. So the workflows are cumbersome and most people have multiple advanced planning systems. They're often overhyped and underutilized. And we focus on quick time to deployment, not necessarily do we have a better answer. So I think that we have a better answer if we've improved forecast value add, and if we've improved schedule adherence and first pass yield, and we've improved the balanced scorecard. That's very different than how most people will actually drive an advanced planning system. So as a result, I'm like, if you're thinking about deploying artificial intelligence, do not put artificial intelligence on the old taxonomy. And this is the old taxonomy. This is what everybody's selling. And the reason is that it puts dysfunction on steroids. We don't need to put dysfunction on steroids. And, you know, the generalized AI, like ChatGPT, is going to put politics and bias on steroids. Our organizations are not aligned. I'm a big advocate of Lora AI, which is helping us to basically use deep learning, but I want to use it on demand flow and I want to use it on outside-in processes, and that's not in most people's understanding because they don't realize the limitations of optimization within boxes in this current taxonomy, and the fact that the optimization within boxes actually decreases the ability of the supply chain to have the lowest total cost, the best margin, the best customer service, and the goals that most people agree on. Superintelligence is a way off, and so let's don't go there. But these are the three forms of AI. So I am a big proponent of Lora AI, but in that process, I want to redefine the taxonomies. I also want to make sure that we are getting better outcomes. And so to that end, I want the solutions to give us information about forecast value added, which looks at what is the value of the planning process so that we can answer, are we making the demand plan better? I also am a big proponent of demand visibility, which shows the coefficient of variation, the demand latency, the forecast value add, and demand shifting versus shaping for business leaders so that they can understand the flows of demand. I think most people have 5 to 7 flows, depending upon if they're configured to order or make to order or, you know, whatever they're doing in their supply chain. Some are service, some are projects. And most people have, you know, 4 to 5 flows, but it starts with the channel. And the outside-in process mines these flows and basically gives visualization and action to the flow for business users. And if we're successful, we democratize the data so that it's self-service. We no longer need 300 to 700 planners. We maybe need 10 to 30 planners that are orchestrators. And the market data is used because today, as you will see, the market data is not used. The other thing that I strongly believe in is the planning horizons. I think that the planning horizons match the planning processes. So the strategic planning horizon, which designs the flows and actually translates the operating strategy into how we should run the operations and how we should design our go-to-market programs, I think is essential to drive alignment. It needs to be done as we're redefining operating strategy. The tactical horizon, which is focused on the decisions we make outside of lead time, is also extremely important. But I find that people will collapse into the reactive world of the operational horizon, which is really daily or hourly within the order duration, and forget about, the need for setting up the right planning horizon. So the operational horizon, weekly or daily, out to the slush period, 14 to 16 weeks, is important. But in this movement on the outside-in process, I'm managing all of the horizons with visibility across the horizons. Now, one mistake people make, I think, is saying, well, let's start with an inside-out process. Let's start with a sales-driven process or a manufacturing-driven process. And maybe we integrate the budget, and then we'll move to an outside-in process. I have studied demand-driven, market-driven for 2 decades, and this doesn't work. The models for outside in and inside out are fundamentally different, and the processes are fundamentally different, and the mindset are fundamentally different. So that's why I have this S&OP maturity drawing, which is kind of the snail's trails that shows the discontinuity between the inside out and the outside in processes. To drive outside in thinking, we must build the models with the goal in mind and use the data and educate people on these processes. So what are Lora's lessons learned, right? An inside out model will never become an effective outside in model, right? So therefore I can't use the current forecasting models to really mine the data for an outside in model. It can't be attacked as an evolution. And I know that's hard, but it just can't be. It's not effective. The other thing is, a lot of times people think, well, if I'm going to be outside in, I'm just going to share forecasts, right? I'm going to ask my customer for their forecast and I'll get a better answer, but that doesn't work either. And the reason is most customers don't have good forecasts, and their definition of demand is very different than your definition of demand. And so I have never found in my analysis of customer forecast a really good signal here. It can be used as an indicator, perhaps to look at how things may change, like, there's a big jump here, but not necessarily to closely tie the customer forecast to the inside out forecast, which many people think they can do, right? And so I was working at a large food manufacturer that had 32 retailers, and they wanted to closely couple their retail data to their forecast. And I'm like, that is going to send you over the cliff. And they're like, oh, we want to be customer driven, Laura. And I'm like, well, let's do forecast value add on the customer forecast first. So we took the 32 retail forecast, we looked at them over time. We did a forecast value add analysis, and we found that the customer forecast had far more error than this food manufacturing forecast based upon forecast value add. So we got to be careful. We can't just assume that a customer forecast is a better indicator of demand and closely couple what we're doing. The other thing is, vendor managed inventory is a good source of demand data. It gives you a pattern with minimal latency. E-commerce data is a good source of demand data, but I don't find that we're using either VMI or e-commerce because they have less latency as a demand signal. We're bringing VMI in at the order level, not necessarily into an outside-in model. We're not looking at the trends of what people are ordering in e-commerce as a future trend in our model design. So good opportunities for us. So how do we go about building an outside-in model? Well, the first thing we got to do is we got to think holistically about the interface, because I want to design the interface for business leaders, not planners. We got to think about the rules, because, we have the opportunity to move from a mindset of single ifs to single thens to multiple ifs to multiple thens. So what does that mean? Well, ATP and allocation wouldn't necessarily have to work in separate silos. And I could bring customer-centric data for multiple ifs to multiple thens and thread the logic much more holistically. And we've got to think about engines more holistically. We've got a lot of opportunity with cognitive computing. We've got a lot of opportunity with being able to see the flow from the graph. We got the opportunity to be able to use deep learning on data. All of this can redefine the engines, but we also need to define the workflows to be able to look at how could people get information? How could we drive cognitive learning? How can we drive proactive insights? Because we're drowning in data and very low on insights. So our traditional models had a single input, an order or a shipment, into an engine, which, we talk about best fit, and, we've got 12 to 15 different types of engines and optimization. Okay, I get it. To a time phase plan. And the focus was on error and bias. So we've got to kind of wash that out of our minds. And we need to move to a different mindset where I've got multiple inputs, and those multiple inputs will change based on the demand flow. So if I've got a service demand flow, it's probably a different set of inputs than if I got a turn volume input, or if I've got a project-based flow. So most of the companies will have 5 to 7 different forecasting flows, and each of these flows will have, 15 to 21 different factors that will vary over time. So the building of the learning engines to be able to look at which of these inputs make the most sense to decrease demand latency and improve coefficient of variation and our outputs on forecast value add is a little bit of a test. It requires, I think, narrow AI, it requires cognitive learning. And so I want to test the building of ontologies next to the graph to be able to drive these learning engines and look at which set of inputs make the most sense and how they change over time. I built a model for agri-sciences that looked at 21 different inputs. We looked at government subsidies. We looked at, how many fields were planted based upon, what was happening. We looked at, how crops were doing. We looked at weather. We looked at, the price of fertilizer. And, those changed over time. And it was a much better forecast than, looking at orders because, the crops are really tough to, forecast. And most of the agri-sciences products are returned at the end of the season. So, we've got to really rethink what is the role of the forecast. The other thing is the output. Who uses this data? In my worldview, the people that use this data are sales operations people. They're the sales account teams. It's the marketing and brand owner. It's the chief financial officer. It's the chief operating officer. It's the VP of supply chain. And so we've built a role-based interface that allows us to take multiple ifs to multiple thens, to answer the questions that they have, and to be able to drive the insights for collaborative workflow. So that's where we get to rules and policy and the clear definition of what is the role of the forecast. This outside-in model has the ability to show you the forecast value add of the model. Am I making it better or not? The latency of the signal of, how far off the channel am I? And the bullet effect, so that as I collaborate and I look at demand shaping programs, and there's 7 demand shaping levers, there's trade promotion, there's price, there's assortment, there's marketing, there's new product launch, there's the combination of this, and then there's digital social media. So each of those demand shaping levers can improve baseline lift. Most of the time, we shift demand from period to period without shaping demand. I laugh with my friends from Colgate of how much toothpaste will we really use, right? We do a buy one, get one free program, but really that shifts demand from period to period because, even though I love my Colgate toothpaste, sorry, Procter & Gamble, I'm only going to brush my teeth so many times a day. I'm pantry loading, right? And that's cost for Colgate. Now, There's an argument of perhaps Colgate drives some market share. Well, maybe so, but how much market share is actually driven versus shifting demand from period to period, increasing cost and decreasing baseline lift? And so what we're going to do in this visibility is allow people to see baseline and to see the effectiveness of shaping versus shifting and to get a better handle on demand flows. This is what I mean by demand visibility in an outside-in model. So, if you took my first class, you know that the order is not a good proxy for demand, right? Today's order patterns just can't be predicted by historic demand. The pandemic distorted demand and can't really be improved by collaborative forecasting because of our bias and incentives. And we also have a longer tail, and the longer the tail of the supply chain, the greater the demand latency and the greater the issues with forecasting. And, it's not time phase data. We lose the value of seeing the flows, and many products are not forecastable today by conventional engines. And because we don't test for that, we have a false sense that we're driving improvement. Hopefully I have convinced you. Maybe not, but the other issue is the demand latency of a long tail, and that many times the conventional order management gives us a very long tail and latent signal. So we're having the wrong discussion. So how do we start in the building of this outside-in taxonomy? Well, let's start with putting in some of the pieces we have today. So hopefully our demand planning model changes to a ship-to model, not a ship-from model. And we're market-driven in our demand planning process using some of these signals. So it becomes a very different engine. We still have manufacturing planning. We still have planned orders that we consume. We see constraints, and we have factory scheduling. We also have deployment and distribution planning. So not much changes there. We're using sales and operations planning less, right? We've added demand sensing, which is looking at, how do I get closer to the channel in that replenishment period? We've moved network design not to just look at asset utilization, but to look at flows and to translate operating strategy into our value chain strategy. And this could be a digital twin. It could be a parallel instance where I'm actually doing optimization and simulation. Okay. But also I'm building a graph because the graph allows me to see flow, and a unified data model, which allows me to bring in the insights from multiple planning systems. And I'm tying to a balanced scorecard, not just to functional optimization. And you may not like my balanced scorecard, but an organization should pick 5 to 7 metrics that they're going to use as a guiding optimization output, because the supply chain is a complex nonlinear system, and I can't just tie to functional optimization. And hopefully the technology will tell me if I have a good plan or not, because that's one of the big gaps that we have today is people don't know if they have a good plan. And I have a planning master data layer that allows me to look at things like lead time variation and conversion rates and what's happening in currency. And it allows me to redefine procurement, because procurement's a big hole. I have a procurement workbench, which allows me to look at alternate supply, alternate bills of material, the cost of inflation, and also procurement constraints. And I can drive those procurement constraints through the sales and operations planning to look at bidirectional orchestration and sales and operations planning. I'm looking at my supplier issues, things like risk and logistics sensing and weather, and I'm tying it to supplier execution of which supply was on time, how did my suppliers actually drive based upon contracts. And so I'm analyzing the supply flow, right? Are we on time? What was the quality? What is happening with my vendor set? And I have a learning engine so that I can look at what's happening there against the planning master data. And I'm also bringing in the data so that I have a real-time perpetual inventory signal, because today's organization will often take 6 to 8 hours to roll up inventory globally, but a NoSQL database will allow me to do that with minimal latency. And then on the demand side, I'm looking at all the market signals, the weather, the events, the social media sentiment. I've got a demand flow analyzer, which is breaking the demand into flow, looking at, high volume, low volume, new product launch, and learning engine, which is telling me insights about that demand flow. And that's going into a new layer, which is giving me demand visibility for cross-functional what-if analysis on demand, bidirectional orchestration, which I'll cover next, and supply visibility, not just the old-fashioned control towers, which I think are worthless, but really looking at supply flow to procurement and looking at what could we do in that supply base. And that procurement is also looking at transportation. And I'm looking at baseline demand of what is that market potential with little latency and plan feasibility to tie to the planning outcomes. So this is Lora's concept of the taxonomy. What I'm going to ask you in session 4 for your homework is to build your taxonomy of what do you think an outside-in planning process looks like, because I think it isn't the conventional taxonomy. And I look forward to your thoughts because, I think we have to redefine what we're doing here. And the rules and policy automation, which allows multiple ifs to multiple thens on the learning engine, helps, I think, a lot. So just refresh your concepts around demand shaping versus demand shifting. These are some definitions on what is the baseline forecast. Demand shaping actually improves baseline. Demand shifting moves demand from period to period. Hopefully in the demand visibility, we have visibility of that. And that demand visibility and supply visibility signal allows us to do bidirectional orchestration. We set up the orchestration levers and the strategic horizon to be able to say, what can I do? And then we pull those levers in the driving of the insight based upon the flows into sales and operations planning. So I'll give you some examples. There are 192 ways to cut up a cow. So, we take market basket information and price information, and we look at what kind of cows we have in the feedlots, and then we say, how do we best cut up the cow to drive margin? Likewise, the American Red Cross, where I give blood, I'm O positive, and they like my blood, even though I'm an old gal, because I'm a universal donor. They use the 22 attributes of blood to decide who they're going to drive to the collection sites, and they use digital marketing programs based upon those attributes to drive respondents to give blood. So driving digital marketing programs based upon what's happening in the market and availability and feasibility is another opportunity. So many times we have promotions that aren't feasible. So whether it's demand shaping programs, to be able to drive baseline lift, allocation strategies, alternate channel strategies, postponement, alternate distribution, alternate routing, alternate bills of material, alternate sourcing, reverse bill of material, contract manufacturing versus in-house manufacturing. These are levers that have to be designed to be able to drive bidirectional orchestration. But the concept is that we would have a demand visibility insight and a supply visibility insight that would drive the bidirectional orchestration, helping people to understand plan feasibility and the output of the plan. So with that, let's talk about some case studies. So you might say, well, Lora, how do you come up with all these crazy ideas, right? Well, I think one of the issues is we're very supply centric. When I ask people to draw their supply chains, they'll start with their products, the green stuff. And then maybe they'll talk about supply chain based on an input. This is a high-tech and electronics case study where they talk about a labor input, right? The no touch, the low touch, the configured order, the high value, and services supply chain. I give them kudos for remembering the services supply chain. MRO is very hard to forecast and really requires a very different technique. And so, one of the demand signals for MRO is getting equipment signals directly to be able to drive those requirements. But the supply chain shouldn't start with products, and it really shouldn't start with supply chain inputs. Instead, it needs to start outside in, from the customer back with the flows and mapping those flows. And that's what outside in is all about. And across the supply chain, we should structure a listening post using unstructured data. And most people don't know how to use unstructured data, but this is a Lenovo case study where they are using unstructured data to understand warranty information. And they can see this, relatively real time. And warranty information can tell us, whether people are liking our products or not. If we have a severe warranty issue, perhaps that is affecting demand. And also to be able to look at regional demand. So this is a Walmart case study where Claritin, which is a product used for allergies, the company would use a cycle that looks like this, not looking at regional demand. And allergies are very regional. And so in this particular case study, they used pollen counts and really looked at regional profiles to be able to look at what the demand output was, and actually worked on the inventory. And you got to understand that this is a very short window. This needs to be a very responsive supply chain based upon time, and the demand latency of this signal is typically 180 days. So I am not going to drive this supply chain off of orders. I need to be driving it off of point of sale data and allergy data, pollen count, weather data, and I need to be doing it regionally. So these are demand flows that you can see vary by region. So let's look at another case study, Linux, which was looking at how can I change the business for MRO. And so, traditionally they thought about, climate on the left-hand side, but really what they have are microclimates. And so what they want is to have effective usage of their equipment across microclimates. So they said, well, how can I use the Internet of Things in each of my deployments to be able to have the machines talk to drive the signals for the requirements for the MRO and service? Worked great. But the problem was redefining the business processes. The customers were fine with them calling up saying they needed a service call, but the distributors weren't, because it changed the margin. So the concept is, how do I change the process so that what's happening in the field is actually talking to my supply chain and is a demand flow? Because MRO is very tough to manage. The other thing is, how do I have my machines talk about replenishment? So this is the deployment of a coffee maker that actually drives a replenishment signal to allow people to do, more real-time visibility of replenishment. This can be used for vending machines, can be used for hospitals, the automation of the local channel. Okay, so we've got a lot of different signals that we don't use. So in Project Zebra, which started 2.5 years ago, we actually started with, let's make some of these concepts real. And BSH is a company that I asked to work with us. In 2009, did some of this work with BSH. And we looked at how could we better sense market demand. This is in the middle of the pandemic, and people were buying a lot of dishwashers, redoing their homes, and the demand was abnormal and it was unusual. And they were having trouble getting parts, particularly pumps for the dishwasher. So we looked at what was the latency of the market signal and what was the latency of the order signal. So the difference is that the market signal is what's driving the market. So in this particular case, it was COVID and it was lockdown. But people would have to redesign their kitchen before they would go buy a dishwasher. So there was a period of time there where there was a redesign. So the market signal was COVID and lockdown, housing starts. The demand latency was the purchase and then the order translation. So the market signal was 3 to 4 months. The demand latency was, 2 weeks to 2 months, depending upon the region. But what we found was that the consumer demand, point of sale, to the channel demand had 2.3% amplification, right, on the bullwhip effect. And the bullwhip effect is the amplification and the noise of the signal, right? But internally, because there was so much disruption, their deployment of sales and operations planning added a 4 to 6 week latency. And many times what we've done on the collaboration internally of sales and operations planning adds process latency, but it doesn't really add value. So the other case study that we'll talk about in session 4 is LKQ. LKQ had a very, very poor deployment of demand and supply planning. And Nicole Miera will be the first to tell you that. They had forecasted at the branch and they had forecasted at the distributing point, but they weren't synchronized. And LKQ likes to fashion themselves as the Amazon for spare parts. So they're trying to ship a spare part with minimal time in Europe for automotive. So we tried the 09 statistical model and we got very little lift, even though it was a poor deployment, right? So better optimizers within conventional taxonomies don't really help us that much. But then we looked at a market-driven model, which was looking at multiple signals. It was looking at our people in offices, COVID levels, driving, new car sales, and we only did this in a short period. But we were able to improve the forecast value add by 17% by looking at market signals, right? A market-driven forecast, right? And so, stay tuned for session 4 where we'll talk about this deployment. I've been following this for 20 years, writing about it. Market-driven demand management outperforms conventional forecasting, but it requires a redefine of processes, and that's hard for organizations, right? When we redefined this for DuPont, we struggled with stickiness because we did not actually push it into the executive level. And many consultants don't understand this, and so there is a push for IT standardization. The DuPont models that were outside in to really look at titanium dioxide requirements were replaced by the one SAP system because they were focused on IT standardization and didn't really understand the value of reducing demand latency, which in the chemical industry, titanium dioxide and the translation of that across layers is 5 to 6 months. There's an opportunity to use more forms of data and to look at demand patterns more granularly, but most companies don't know the data they have. So one of the most fun I have is when I go into an organization and I get the digital marketing teams with the supply chain teams and we talk about a gap of performance in a recent period, and we talk about how could we have used data differently? How could that model have changed? And how could we build a demand visibility signal? Most people don't know what's possible in technology. And so I find that technologists know the technology and the business leaders know the problem, but it's hard to get a safe space for people to talk. And that's the goal of this class. And the other thing is, I think there's a great opportunity to manage demand as a flow. That requires a change in mindset, and that's where we're going next. So let's draw demand as a flow, right? The first time I did this was when I was hired by a chief financial officer to answer the question of why is my company shorting cases? Tremendous deductions in the North American market. And one of the issues was they didn't know if they had a good demand plan because they didn't understand forecast value add and they hadn't backcasted and they weren't sure what a good demand plan was. In fact, one of the things that happened was we put people in the room to talk about demand that had never talked before, right? The demand planners didn't know the transportation planners and the sales and marketing teams didn't really know the demand planners. So we started with what is a good plan? How do we measure forecast value add? How many demand flows do you have? What kind of data do you have? How do you use forecasting? What is the role of the forecasting organization? And a lot of light bulbs went off, but we found a lot of gaps. And then we found that 75% of the cuts were actually due to the river demand. And let's talk about that. So this is a food manufacturing company. They had 85% of the channel data in the sales teams. They were like, well, we can't use that data because it's not perfect. No data will ever be perfect. But we started working on machine learning and mining the patterns out of the data, and we found great insights, right? And then we found that this organization had inventory technologies, but they didn't want to deploy the inventory technologies because they thought that they weren't given a good plan because they had never defined what is a good inventory output. So they had a problem with phase in and phase outs where they changed the packaging and code A represented product A and B, and then code B changed because of the packaging change. So they didn't really have the logic to be able to look at phase in, phase out, and to be able to look at, how could we merge the demand for those products, because we were dealing with such a SKU level model. So when we talked about attribute-based forecasting and actually looking at how do we group those SKUs, it helped with the phase in, phase out of that problem. We also found that there were 22 million unforecasted cases. So every time marketing was going to shape demand, they actually had a spreadsheet and they said, oh, by the way, let's do this program. Well, those cases were never forecasted. And this division would always under forecast to make their bonus. And these extra marketing cases caused us to overflow the dam, and we were heavily asset utilized. And so we weren't able to actually make all of the capacity. And so therefore we shorted cases. So what can we learn from this case study? Well, we've got to start with what is the role of the forecast and what is a good forecast? And what are the flows and what are the data and how do people work together? And so they came up with this plan and we started a sprint. I can't say that it was wildly successful because we were never able to get past the political governance issues of under forecasting to make the bonus. But I think there was a lot of learning that happened. And in this particular case, they had a long tail, and this long tail had inconsistent demand. 1,723 items represented 23% of the volume and 26% of the net sales. So reducing the tail, reducing the complexity was an opportunity. And they learned what was forecastable and what was not, so they could change their manufacturing strategies. We talked about this case study in the prior work. This is a similar case study where there is a governance issue that we're under forecasting in S&OP. And so therefore, we put all of our effort in S&OP on how do we manage the budget to basically make bonus incentives. And because we're under forecasting, we aren't buying the right equipment. And so our asset utilization is out of balance. And, we also aren't managing cross-functional flows across regions. And so the affiliate demand throws the supply chain out of balance. Affiliate is another region ordering from this factory. And they have a policy that they put in place that says, if you get affiliate demand, you're going to stop production and you're going to run affiliate demand first. So heavily asset utilized. They're not really clear on what can happen at the asset level. What is the potential? What is the feasible plan? And they cause a lot of issues on cycle stock management by short cycling the manufacturing lines. So the lack of understanding of manufacturing scheduling, they didn't actually have a manufacturing scheduling tool to allow them to see the impact of a feasible plan, and the lack of understanding of supply chain fundamentals and totality was a major issue that caused a lot of procurement issues, a lot of flying in of raw materials, a lot of cost, $12 to $15 million in cost that didn't really need to be there. So this is one of my favorite case studies that we actually have done the animation of. The animation shows that this company has lots of data that they don't use. In fact, this company is, in the Gartner Top 25, wildly hailed as the benchmark company of supply chain excellence. But look at what's happening. All of the data is flowing through gates And we're not really looking at the flow. We're looking at, the data and pieces and marketing and sales. And then we're tightly coupling the budget to transactional data. And we're attempting to do segmentation, but because we don't have rules and policy, the segmentation can't stick. And so it's a very manufacturing-centric organization. So they're very focused on manufacturing scheduling, but they're not really looking at the flow of demand. They're not understanding the latency of the demand. And they're outsourcing their new product launch to contract manufacturing, which sits on an island tethered by spreadsheets, not really controlled. And the new product launch process has got a push-pull decoupling point that changes based upon the flow, but nobody's really seeing it. And then they have a lot of issues of master data. But look at procurement. Procurement is sitting really in a wasteland without really good data. It's very murky in the procurement and logistics area because it's very manufacturing centric. We don't really have an end-to-end process. We have, the automation of an order stream to a distribution stream to a manufacturing process, but not to procurement, not to contract manufacturing, not to logistics. And so as procurement and logistics become a constraint, there are issues. And as contract manufacturing can't really synchronize with the market, there's an issue. But people play root cause analysis to really look for the blame game, not really to design the supply chain holistically. And then in apparel, we've got a lot of attempts to bring in, customer data through either, people agreeing to early buying of products or looking at, assortment. But the translation of demand in attributes that are usable by the entire supply chain just doesn't happen. And so there's an opportunity to rethink the apparel footwear supply chain, really to look at attributes and customer insights and to match customer insights with attributes and demand flows, to look at assortment, look at regional assortment, look at channel plans, to look at demand shaping, and to drive better demand alignment. This is a case study that will be talked about in the fourth session on demand visibility on new product launch with Nestle. And here we're looking at how much latency a new product has. You'll be surprised, right? It's weeks. And the lack of, ability to manage contract manufacturing. And notice that we've got all this data upstream with the sales and marketing groups, but we don't have the insight downstream, which is why the water is dirty and murky. And you'll notice the eddies because we, have the pull as we stuff the channel, and then we have supply, but we're not actually able to navigate the change in the shoals of this particular river. And syndicated data, IRI and Nielsen, also has 2 to 3 weeks latency. So in the demand visibility, how do we get data with minimal latency to drive improvement? Large chemical industry. This industry sits, 5 to 6 months back in the market. This is gated in the beginning on the S&OP process, which says this is the product that you'll make. And the processes are never really aligned with the market. And they have manufacturing plants that are told that they can never say no, even though they have limited capacity, because they don't have visibility of a feasible plan. They don't understand a feasible plan. And the transportation processes, even though this company has, TMS, are never really controlled. They're managed by an outsourced 3PL on an Excel spreadsheet. And so, we talk about automation of processes, but you can see from these examples, we're far from automated, right? And so this is a discrete manufacturer that is struggling with, add-on orders and the inability to see alternate bill of material, alternate supply, and manage special projects. So what are the insights, right? Today's demand planning processes serve DRP well, but leave the rest of the supply chain in murky waters. companies don't use the data that they have, and S&OP is not the panacea to drive alignment, primarily because of political and governance issues and the fact that people don't understand what a feasible plan is and they don't see what is a good plan. So I'm hoping that by changing the taxonomies and by changing how we think about planning, that we can make this better. And you're far smarter than me, so I'm asking you to let's go on this journey together. And so your homework is to map a river demand. I want you to take a customer that you work with. You can do this in a team or you can do it individually and send it to me by Thursday night at midnight, because we'll talk about this on our Friday session. And basically map demand flows. So, service flows, program flows in high tech and electronics, perhaps configured flow or a turn volume flow, a new product launch. So map your flows, look at all of the insights that you could use in these flows and the barriers or the rocks that you have and the eddies where data goes back and forth across organizations, and how you tie this to a balanced scorecard and how you move it from the customer back with minimum latency. And then draw your river. And I've given you some examples in your LinkedIn chat. Look at how do you minimize the coefficient of variation, and how do you improve out of stocks, and how do you improve effectiveness. So let's have some fun. I am not looking for if it is artistic. I'm not expecting you to be a Picasso or a Chagall. I'm looking for thoughts, right? I'm looking for how can we improve flow. So my name is Lora Cecere, and I'm all about changing our processes to be more effective. I apologize for the technology issues we had today. I had a series of tornadoes that hit Pennsylvania last night, and I'm running on backup power, and I just couldn't get Zoom to work today. And also keep Regina in your prayers. If you know Regina, she was having surgery today, so I couldn't reach out to Regina to help. So I was kind of stuck, and I apologize for that. But hopefully this recording will help, and you can get your river demand drawn by midnight on Thursday, and we can have a great conversation on Friday. Thank you.